operations on functions. Now we're going to do this combination of two functions. So another method used to combine functions is a composition of functions. Okay, so we have a composition of functions. In a composition of functions, the results of one function are used to evaluate a second one. Okay, so in words here, suppose f and g are functions such that the range of g is a subset of the domain of f. Then the composition function f of g can be described by f of g of x or f of g of x. Okay, so this is how you'd see this composition of functions on your piece of paper. So it's that open circle between f and g. Okay, you have that open circle between f and g. So the composition of two functions may not exist. Okay, so you may have no solution. Given two functions f and g, f of g of x is defined only if the range of g of x is a subset of the domain of f. Likewise with g of f. Okay, so you can find both f of g and g of f. So in example 3, for each pair of functions, find f of g of x and g of f of x if they exist. For part A only, state the domain and range for each composition of functions. So we can state the domain and range. So for the first one, part A, we want to find f of g. Okay, so again, you have this open circle. We want to evaluate g of x first, and then we want to find that domain and range. So we're given these points for f and these points for g. Okay, and we want to find f of g of x. And that's how I'm going to kind of write it all the way down. So that means I'm going to start with the x's in g. Okay, so I'm still going to have f of g, but I'm going to look at g, and I'm going to look at all of the x values in g. Okay, so my first x value in my g function is 7. So I'm going to plug in 7 for x. So now what this is saying for evaluate g of x first, you want to evaluate g of 7. Okay, well if I were to plug in 7 for x, my y value for g would be 0. Okay, so evaluating g of 7, I would have f of 0. Okay, are you following me why I'm doing this? So I plugged in the x value 7 for g. Okay, then I move to evaluate g of 7, that would be 0. Okay, so instead of g of 7, I now have 0 because that's the evaluated form of that. So from here, now I can find f of 0. So now I need to look at my f function. I need to see if there's a 0 as an x value in f. There is. Okay, this one right here. So evaluating f of 0, what would my answer be? -1. You can. You're going to practice it some more. Okay, so next, I'm going back to my g. Okay, what's my next x value in g? -1. What is g of -1? G of -1 will be equal to 7. So I would have f of 7. Then I want to look at my f function. Okay, I have an x value of 7. So f of 7 will equal 7. Okay, what's my next g value?
It's 4, right?
Yep.
Yes, sir. And then it's 9, right?
Yeah. So g of 4 will equal 9. So I'll have f of 9. Okay. f of 9. I need to then look at my x values in my f function. Okay, I have a 9. So f of 9 will equal its y value, which is 4. Okay, I have one more x value in my g function, that's 8. So I'll do f of g of 8. Okay, g of 8 is equal to 2. So I end up with f of 2. Look at my x's in f. I do have a 2. So f of 2 will result in 6. Okay, so I do want to write out my values for my f of g function. Okay, so here I have f of g. Again, that's an open circle. So f of g of x. I'm going to put a bracket, and I'm going to make these as coordinate points. So whatever I plugged in first a 7. Okay, my result was -1. So I have 7, -1. Add in a comma, yep. Next, I plugged in -1. Okay, it gave me 7. Okay, then I plugged in 4. It gave me 4. You did this last year. Okay, then plugged in 8, gave you 6. Okay, so that's my range of values for my f of g function. Now it also wants us to evaluate the domain and the range. Well, with coordinate points, it's really easy. Okay, so our domain are x values. So the values we plugged in. So the lowest x value we plugged in was -1. Then 4. Then 7. Then 8. That's your domain. It's just the x values that you found or you plugged in. Okay, then the range would be the y values that you got. Okay, so our y values that we got are -1, 4, 6, and 7. It's just coordinate points. Okay, so that would be your domain and range for that composition of functions. Questions? Do you understand how I got each of those values? I tried to do it kind of slow. Yeah? All right, so the next part here, we're going to do the opposite. So we're going to do g of f of x. Okay, so this time we have g of f of x. So this time you're looking at your f function first. You're looking at the x's in your f function first. So starting this off, I would have g of f. My first x value in my f function is what? 2. Yes. All right. So if I plug in 2 in my f function, what y value does it spit out? 6. So that results in g of 6. So now this is where I can look at my g function. Is there a 6 for any of these x values? No. That means there is no solution for that one. Okay? So we're going to keep going. Again, we have g of f, moving on to my second f point here, my x value is 9. Okay, evaluating f of 9, we end up with 4. So I have g of 4. So I can look at my g function. Do I have an x value of 4 in my g function? Yes, I do. So g of 4 would give me its y value, which is 9. Okay, next we have g of f of 7 would be our next x value in f. Now f of 7 is equal to what? 7. So I'm looking for g of 7. So is there a 7 as an x value in g? Yes. What does it equal? Okay, last one here, we have g of f of 0. Okay, f of 0 will equal -1. So we end up with g of -1. Okay, I have a g of -1 as an x value. That equals 7. Okay, so from here I want to write out my g of f of x function as coordinate points. Okay, so this one I can't use. That one didn't work. Okay, so that's not a coordinate point. We can use this one. So I have 9, 9. I have 7, 0. And I have 0, 7. Okay, then I want to write out my domain. Okay, those are my x values. So I have 0, 7, and 9. And my range are my y values. So again, 0, 7, and 9. Make sense? Any questions before we do an actual function combination? Will you get off your phone?
It's
Yeah.
it's my sister. She has to have her ride. She makes me this thing. I texted the number to whatever phone you called off.
All right, so we're going to
It's 5494.
do a combination of functions now, or composition of functions.
Yeah.
Okay, so instead of just coordinate points, we're given the function this time. So we do want to find f of g of x and g of f of x. So again here, finding f of g of x. So with that one, we're going to take our g of x function and plug it in for the x values in f. Okay? So in words here, we want to plug in g of x for every x in f of x. Okay, so you're plugging 2x minus 1 for each x value in f of x. Okay, so I have an x value here and an x value here. Those are two places I need to plug in 2x minus 1. So wherever you see an x in f, I'm going to leave an open space there. So I have 3, leave an open space. That open space is squared. Okay, so instead of writing x, I'm leaving an open space here. Subtract, again, that open space. Add 4. Wherever you see an open space, that's where you plug in g of x. So you plug in that entire function there, 2x minus 1. Does that make sense? From here, we want to simplify. Now, if I have a quantity squared like this, do I distribute my square? No. Square means you're multiplying one thing by itself. Okay? So that means you can rewrite this as 2x minus 1 times 2x minus 1. You're multiplying it by itself. Okay? So separate that so that you can FOIL it out. Okay, then we're still subtracting 2x minus 1 and adding 4. Can't distribute the square. Can't distribute the square. Alright, so from here, I'm going to FOIL these two. So multiply my first, my outer, my inner, my last. Okay, so 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. Negative 1 times 2x again is negative 2x. And negative 1 times negative 1 is positive 1. Now with this quantity here, what do I have to do with this negative? You have to distribute it. Okay, so multiply 2x by negative 1, multiply negative 1 by negative 1. So I have minus 2x plus 1, then plus 4. What's my next step? Distribute the 3. So distribute the 3 to all the numbers in there. So I end up with 12x squared minus 6x plus 3 minus 2x. If you want to combine these right away, you can. 1 and 4, that's just 5. From here, it's just combining like terms. Okay, so we have 12x squared. I have a negative 12x here, then another minus 2x, so minus 14x, and then plus 8. Now we have to do g of f. Yes. That one doesn't take as many steps. So that was finding f of g. Do you have questions on how I did that? So next, what we want to do is find g of f. Okay, so g of f of x. Again, I'm going to write this out. So instead of plugging g in for f, you're plugging f in for g. Okay, so leaving that open space for the x value in your g function. Okay, so my g function is 2x minus 1. So I'm going to leave that open space where my x was after the 2, and I'm still going to add in that minus 1. Now where that open space is, that's where you plug in your f of x function. Okay, so from here, all I have to do is distribute my 2 to all those numbers. So I have 6x squared minus 2x plus 8. And I still have that minus 1. So I end up with 6x squared minus 2x plus 7. Again, that one was a little bit easier to simplify. Okay, so you're doing this composition of functions for coordinate points. That's what we did on the front. and for functions. Okay, so you're plugging one function in for the x values in the other.
Sorry, I couldn't quite hear you.
Okay, Siri. I didn't say Siri. I don't really know. Don't really know what was going on there. Again, you only have 4 problems. The 2 on the front, you're doing what we did on the front side of our note sheet with coordinate points. The 2 on the back, you're doing what we did on the back. So you have to find f of g and g of f for each one. So I gave you a lot of room.
I think so.
Alright, you have to do f of g and g of f. You have to do both. I gave you a lot of room so you can spread it out a lot there.